This project is about generating 800 digits of pi using a steam engine and an ESP32C6 microcontroller. Here is an overview of the equipment. After this overview, there will be no more shaky camera. We'll be moving to a tripod, so don't worry about that. An LCD is used to display the results. The first step is filling the boiler with water. I've previously filled it to halfway, so this is just sort of a demonstration of topping it off. Distilled water is used, and the funnel is a combination of a kitchen funnel with part of a plastic pen. The water level can be seen on the tail end of the boiler. Now we'll close up the boiler by first testing the safety valve and then screwing it into place. Now comes the steam oil. We'll add some steam oil. We only need a couple drops. I bought this bottle off of eBay, so this should last for a little while. Unscrew the place where the oil goes. The steam oil gives the exhaust steam a nice aroma, and it possibly has some other benefits for the engine. Before the video, I've oiled the motion works with some light sewing machine oil, so that's not demonstrated in this video. Spin the wheel a little bit to make sure that it takes up the oil. Not too sure what this does, but it's fun to do. Now comes the fuel. We're going to be using ethyl alcohol. Got this off of the old Amazon. So it has a nice smell to it as compared to the isopropyl alcohol. But so we're going to avoid spilling it all over the place, I've moved to the sink to pour out 10 milliliters into a little measuring thing. And we're going to take some of the alcohol and put it into an inkjet refiller so that we can prime the burners later on. Take out one of the burners to provide a refill place. The funnel has some water in it left over from filling the boiler, so we'll blow out the water so we don't get water in our alcohol. There, that's better. Now we dump in the 10 milliliters. The tray actually holds 20, but it's easy to spill it all over the place, which would not be a good thing once it's on fire. This is the priming. This helps a lot in getting the burners started, dripping some alcohol onto the tops of the burners. A mistake was made at this point. I should have put the burner cover on next, but I got excited about lighting it. This is really a bad angle for doing this, so I move quickly. You note the flames were almost invisible. Okay, now putting this in place with the flames lit is not as pleasant as if they weren't lit. So we tap it down with the tweezers come with the steam engine kit. They're quite handy. So there's a bad angle again. go to the other side. We don't want to spill all that alcohol over the place. Careful. Whew. Okay, now it's 6 minutes later, and we're almost up to steam, and we can do some other prep steps when we have to get our cooling tower set up. I don't have one of those nice hourglass ones like they use in professional power plants, but this thing from the Safeway seems to work pretty good. So we're going to open up the drain cocks, just like on a real locomotive. That little throttle valve is really handy, but it gets quite hot. So I always reach for it first because it looks nice, but it's always best to use the tweezers. Test. Oh, the whistle's not feeling good at the moment. You'll hear it later when it's happy. Okay, we adjust the reversing lever, which also runs the cutoff system. This position seems to be best for smooth running, where I've got it locked in. I'll tune it up more a little later. This engine, the flywheel works best running counterclockwise from this view. The top of the lever indicates what the top of the wheel will move at. You can hear it spitting and sputtering. It's getting ready to go. And there's droplets coming out of the drain cocks. A little cleanup. Try again. Oh, now we're cooking. So we quickly close the drain cocks. Adjust the reverser for a nice smooth operation. It has a tendency to come loose, so I have to check it occasionally. Our cooling tower is producing lots of nice aroma. We'll slide over to the power and computing side of the operation. Okay, we'll hook up the electric power. Turn on the voltmeter. Uh-oh, no volts. What could be wrong? Meter's okay. Bad connection. Okay, now we've got 5 volts. Note that our computer's computing. We've got numbers coming on the LCD. The engine slows a little bit when it comes under load doing the computation. I'll show more details of this display later on. That rat's nest of stuff up there is a logic level shifter for switching ESP 3.3 volts to LCD 5 volts. The voltage is a little high, so I'll close the throttle a bit. Warning, there'll be a whistle test coming up. Danger. Okay, we made it through that. Now we're going to reset the CPU so we can do a close-up of a run to show the numbers in greater detail. So it's going to be displaying the 800 digits of pi and 25 pages of 32 numbers each. A little adjustment so we can see it better. The algorithm used is a C program by Dik T. Winter. In phase 2 of the program we're going to run the algorithm 100 times, and it takes 7 seconds for 100 times through the algorithm. The mathematician William Shanks attempted to compute 707 digits of pi in the 19th century. Although he had access to steam engines, a critical piece of equipment was missing that I happened to have. He spent hundreds of hours, days, months, years working on the computation by pen and paper, and he made a mistake. Oops. Whistle test, whistle test. I'll just let the steam engine slowly die down as it runs out of steam.